Welcome everyone to the DS Incubator. Today we have Monika as our privileged guest. So, awesome guest. So go ahead, Monika.
Hi, thanks Mauro. Hi everyone. Thanks for joining. As Mauro said, today I'm going to present a demo of the r2dii.plot package that we developed together with Mauro actually some time ago. So let me share my screen with you.
Cool, we can see it.
Can you all see it? Yeah? Okay. So my idea is to actually basically go through the documentation of the package that you can also find online and that I shared a link to with you in the Slack channel. So you can also see it like in a website form where you can actually copy each of the code snippets that I'm going to run and you can run them yourself. And I'm going to do it in RStudio. And it should take about 20 minutes for me to present, and I think it's best if we leave the questions to the end, because then if someone just watches it later as a kind of documentation, then it will be less interrupted. So let's do that. And Mauro will tell me when it's 20 past, and in case I'm still not finished. So I'm just going to run some setup steps. And the r2dii.plot package is built to work together with the other r2dii packages, so the data match and analysis. And it's also built using ggplot or ggplot objects. So basically you can use ggplot functions on the objects that it returns. And I'm going to use the demo data from the r2dii data package in this presentation. And when you have real long data, you use, of course, your own data. So here we apply functions from the match and the analysis packages to get a data set that's, how do we call it? Edited, or whatever. So the r2dii.plot in principle supports or has three kinds of plots. It's emission intensity plots, technic plots, and volume trajectory plots, which are the usual plots that you would use to visualize spectral results. But it also has some additional functions that you can use on any plot. So also ones that you create by yourself, and I will show it later. And for each of these three plots, we have two kinds of functions. One is a quick plot, which is very standardized, and you just apply it on data straight away. Well, after some filtering, you can just apply it on data and get a plot that looks pretty good already. And there is also there are also plot functions which are closer to what ggplot would return if you would apply it on your data, but it just a specific factor related plot will be returned in this case. And as I mentioned already, in general, our plots assume that you did some filtering on your data, because usually they are done either for one technology or for one sector. So before you apply the functions, you should filter your data accordingly. And if you want to know the requirements, you can run, like check the help file. For example, if you run question mark plot techmix, you will see the help file, and then you can see what are the requirements for data set that goes into this function. And also, in case you didn't do it correctly, we also try to do error messages, very informative, so they should also let you know what's missing. So let's have a look at the quick plots. So as I said, they are standardized to what you would usually want to see with PACTA results, and they have a lot of underlying assumptions and some customizations that we applied kind of for you, and they are very good to have a quick look into your data, but also for users who are not very familiar with R, because the only thing that they require is when you have the matched data set, you calculate the targets. That's still analysis part, and you just need to filter your data. So for example, here we will create an emission intensity plot, and we filter for cement sector because this is the sector that we want to plot. And then we just run qplot emission intensity on our data, and we get a plot which has a title that is assigned to this plot already, and it has nice labels for each color and also nice labels for X and Y axis. Also, it assumes that you want to plot 5 years of data, which is usually the case with PACTA data. And the same, we also have a quick plot for volume trajectory, which is used with market share like data from the analysis package. And again, you need to do some filtering. So this plot works for technology. So you have to filter for one technology and also for a region, and you get a plot which looks pretty nice, we think. And you get title that's already set, and subtitle, and nice labels and things like that. The same for the techmix chart. You can create a quick techmix. Again, with market share like data, and also here you have to do some filtering for metric column, because you need, for this plot, you can only have one scenario row, which is the target, so you have to pick your scenario. And yeah, you also have to filter for a sector, because this is a plot for a sector. And then again, you get a plot for 5 years time span with title and nice labels. But then we also have the plot functions, which are much more bare bones. So they plot the data as they are, but they allow you for a lot of customizations. So you can make the plots more the way you want them to be and not using our default settings. And there are 3 strategies that you can apply to customize your plots. You can use the plot function's parameters. There are some parameters that also allow you to basically replicate the behavior of the quick plot functions, or almost replicate the behavior of the quick plot functions. You can modify the input data, and you can also use ggplot2 functions on top of the created objects to can add labels and things like that, and I will show you in a second how it could work. So first let's look at how you would use strategies 1 and 3. So if you would want to use the parameters of the plot emission of the plot functions and the ggplot functions. And we are going to do it based on the emission intensity plot example. So again, we need to filter our data for a sector, and at first we are just going to look at how the plot looks if we don't do any customization, so just how it comes out of the plot emission intensity function. And you can see that it just plots the data as they are, and it infers the labels from the data just as ggplot does, but without any modifications. So the labels are not title case, and you have the dash in between, and also the year, like the time span of the data is just as you passed it to the function. And now what you can do is you can use the other parameters that are in plot emission intensity. So like here is the tech mix. So if you check the help for this function, you can see that it has also parameters called span 5 years and convert label. And you can use these parameters to modify the plot. And convert label will take a function to apply on the kind of raw labels of the plot. And then span 5 years, it's again this typical PACTA assumption that you want to plot 5-year data, so you can just use this parameter to restrict your data set. And then we use the labs function from ggplot to add our custom labels, so to add a title and X and Y label. And if we run this code, you get much nicer plot. So you get a plot again for 5 years data and with some nice labels that you chose. Another way to customize your plot is to modify the input data. So one of the ways is to, for example, filter the time span in the data. Another thing that you could do is to add columns, label and label tag, which are then used by our plotting functions for the labels. So normally the plotting functions kind of create this column for you, but if you add it yourself, then it will use that instead. And again, you can modify the output ggplot objects that we already did with the labs ggplot function, or you can change the color using the color scales functions. We also have our r2dii.plot scale functions that you can use to change colors in your plots, which I will show in a moment. But for now, let's still look at the plot functions. So, for example, for the emission intensity, here we add we use the labs function to add title, just as we did before. And we also use the scale color manual, which is also a ggplot function. And we pass some color values in forms of hex codes and labels that we assign to these colors. And we get a plot with our own colors. And here, if you use this, and also with the time span that we chose. And here you have to pay attention to the order of your data that specifies the color. And sometimes you might need to use the factorization to get the right order of the colors, or, well, the order that you wanted. And the same for plot trajectory. For example, we can add a label column to our input data, which is basically modifying the metric column, which is the output of the market share. So if we add this label column, it will use that to label your trajectory plot, and again, you can also add your title and things like that. And we get a plot with your own labels for the scenario lines and for portfolio and benchmark lines in this case. And finally, for the tech mix, again, you can add this label column. You can also add a label tag column, which will change the labels for the colors. Here we do it differently because we also want to customize the colors. So we don't want to use the Pacta technology colors, but we want to use our own colors. And then we use the labels parameter from the scale field manual function to add our own labels for the colors. And then you get a tech mix plot with the colors that you specified and also with the names for the colors that you specified. And finally, we also created some styling functions that you can use for any plot. So one of them is the theme to the AI function. Theme to the AI function that works like a ggplot theme, and it gives you our plots with our 2dii styling, which is basically it's based on the classic theme from ggplot, and it creates very clean plots compared to original ggplot output. And also we have our custom scale color and scale fill functions, which you can use to modify colors in your plots. So for example, here I will plot the production over time, and it's just a line plot. It's not any plot from the r2dii package. And then I use the scale color r2dii with labels that I specify, also in the order that I want, to use 2dii colors in my plot.
10 minutes to go, Monika.
Okay, I'm almost done. And basically you can do the same, but using 2dii sector colors, which are basically the colors that are assigned to pacta sectors, and you can run that on your ggplot. In this case, it's a bar chart to get this colors that we usually use, for example, the blue for automotive and the orange for power. And again, you can do the same, but with using technology pacta colors. So like here we will have power colors. So these are shades of orange that you can apply on your bar charts if it's showing technologies from the power sector. And just one more thing about the colors. I'm actually now working on r2dii colors package that should make these last functionalities even easier to apply. So stay tuned. But for now, you can use also these functions to modify your plots. And thanks a lot for the attention, and I welcome all the questions.
Thank you very much, Monika. That's awesome. Question and comments, please.
No questions. So I can also just say one more thing, that someone has a question. Antoine?
I had a question. But
Yeah.
go ahead with your comment. Like that can be a final question. That's not really related. That's more related to visualization than what you present. So go ahead with your comment.
All right. Yeah. Well, I just wanted to say that, of course, I'm very happy when people use this package, and I encourage everyone to do so. And also, if you do, and if you encounter any issues, or maybe there are some features that you would like to see there, or maybe some plots that you think would be really useful, you can always use our GitHub page and submit a new issue to let us know about the new features that you would like to see, or bugs, or anything like that. So Antoine, you can.
Yeah, that was more related to the emission intensity chart and those type of chart where there is some line, and that's just something I don't remember how to do on ggplot, and I already had a look and can't really find something satisfactory. But if you want to plot a dot line, for example, what should you add? Should you add something in the scale line manual input, or?
Yes, as far as I remember, but actually I would have to check that. The same as you specify an aesthetic for a color, you also can specify an aesthetic for line type or something like that. Like, I would have to check the name. And then indeed you have a scale function that's then modifying it the same as you modify a color later in ggplot.
Yeah, okay. Thanks a lot.
CJ?
Yeah, so congratulations on getting this package to where it's at. Been a long road, but it looks really cool.
Thanks.
I wanted to ask or clarify, I mean, I think I know the answer, but so also like the color, the things that apply the r2dii colors, and then also like the r2dii theme, those can also be used in like a completely customized chart as well.
Yeah, indeed.
Yeah.
Maybe I didn't make it clear enough, but here in all the examples from the styling functions section, I actually don't use r2dii.plot functions. I just call ggplot. So like, I just make a ggplot with column plot, or here it's a line plot. So I just use the geom line. So yeah, you can use it for any ggplot on any ggplot object. Mauro?
Thanks, Monika. I wanted to kind of maybe make like a very general comment that is motivated by the fact that I'm working with a new team in a new project, and some people have joined recently, so they are not familiar with the entire ecosystem of packages that we have been building or how they are born, right? So I just wanted to highlight that Monika's package is like a story of success in the feedback loop that goes between analysts and developers, and in this case her also as the specialist in visualizations, where all these kinds of plots existed somehow in very different in very different forms, and done, each analyst could do something like this their own way, maybe using Excel, maybe using R, but basic ggplot2, or maybe using base R or whatever. So I think it's really important to highlight that if you're new to r2dii, that the developers here are there for you as a resource to take your patterns, your workflows, and take them to the next level, where the code that you write becomes something production ready and something that you can then use like very, very easy, and not only benefit you independently, but also kind of help you work in a very consistent way across the organization, meaning that 3 different analysts all using Monika's plots, they all have the same they all benefit from the input that Monika has put into designing those plots. So yeah, just leave it there. And also that the package and website that Monika showed is not only for this package, that every package that we are building has more or less a similar structure. So as Monika showed, there is a website that relates to this package. So if you need to read documentation, you don't even need to install the package. You can just go to the website. So what this presentation is yes, specific about r2dii plot, but a lot of the patterns that she showed here apply to many more packages in our ecosystem.
Yeah, indeed, thanks. And yeah, that was the idea with this package, to just make the work of the analysis of the analysts easier, or that they don't have to do they can do the analysis instead of figuring out how to plot something that has been done before. And I see hands from CJ and Daisy, but I don't know who was first. So maybe Daisy.
CJ, I think you were first.
Okay. I have 2 quick questions about preemptively imagining what could go wrong. So one is, are there any hard-coded things in the functions that one should know about? It expects only sectors that, specifically the sector names that we have used in the past, or scenario names, or something like this. So if we added a new scenario or changed the name of the scenario or the name of a sector, would this easily adapt to that? And then also in a somewhat similar vein, what happens when the data necessary to show the chart isn't in the data frame that you passed? Does it give you kind of meaningful warnings, or you don't have the data you're looking for, or something like that? Or is it? Yeah, so I'm just curious, because I can imagine that would be what would catch people.
Yeah, so in general, yeah, it expects a certain shape of data that is currently based heavily on the output of the analysis package. So banks kind of data, as we also call it internally. And yes, so some things are inferred from it, and on top of my head, I cannot tell you everything. I think, yes, the sectors might be assumed to be just de facto sectors, and the portfolio is assumed to be called projected in the metric column and things like that. And actually, one of the things I want to work on is to make it a bit more flexible, but then at the same time not too flexible. And with the other question, we try to make the error messages as informative as possible, so that if people don't have the data in the right shape for the plotting function to work, then we try to inform them not only that there is an error, but also why and what can they do to get the data in the right shape. Daisy?
Thanks, Monika. I try to be super quick. Again, really thanks for this. This is great. I think I can speak for all of us as analysts. It has been really helpful. We were doing these plots in Excel. I think Antoine also knows this. So this is really valuable for us. But one thing that I've noted, and so I would like just to search for your advice on what should we do when we want to save these plots. Because I realized that, okay, maybe Antoine and I are working on the same project together using the same data, but when we want to save the plot or save it as image or save it as PDF, we get kind of different versions. Maybe Antoine's version is bigger than mine, and if I want to replicate, then we need to do certain changes. So I'm just looking for some advice on how we should handle this. So if I want to replicate something that Antoine did or the opposite, we make sure that we get kind of the same image, the same size of the image, the same resolution. Just looking for advice on this.
As far as I know, this can be quite complex because sometimes it's dependent on your settings, like your R settings and also your computer settings. I mean, you would save these plots the same way as you would save a ggplot object. So you can either save it in, like, if you view it in the, I think it would be here maybe if I would run some code, and then you can, no, probably not upload, then you can export it. You can also save a ggplot object, like there are functions to save an object, and then you can also specify the size there. But I think even if you do that, you might still end up with different plots. To be honest, if you have like different computers, different operating systems, it can still be an issue. Antoine?
Yeah, in the short term, I was thinking like what we use is the ggsave function, and I was like knowing that it was possible to set the plot size, which I don't really do for now because I don't really use like when I save them, I also copy paste and directly put them where I need. But that I think would be a short-term solution. But maybe also you're right, like maybe even if we set the size on ggsave, that will give different result. I'm a bit not 100% sure. Like I think that's something we should try and see if it works.
Yeah.
Thanks, everyone. In terms of that, that makes me think that maybe, Monika, we can have a conversation about if we need, for example, in the vignettes to show, how people can do that, even when that's not a feature that we ourselves develop, and the features are, out there from ggplot or from whatever. But it sounds that it is part of, the analyst's workflow, and we may need to experiment a little bit and decide what would be a good way. So that different analysts could export the figures in the exact same way. Thanks for the idea, Daisy. It's something that honestly I haven't thought about. Maybe Monika did, but I didn't. And maybe we need to wrap up. So I'll leave it to you, Monika.
Yeah, thanks a lot, everyone, for all your questions also. And indeed, also, if there is any something about plotting that you do often and you often struggle with, then also please let me know, because then I could write some article like what Mauro mentioned about how to do it, if it's not, even if it's not like the code that I wrote. And yeah, good luck with using the package.
That's cool. Thanks, everyone. See you
Thanks a lot.
next Tuesday.
Thank you. Bye.
Ciao, ciao.
Bye bye.
Monika, would you stay for a second? Oops.